What we have here is one of my favorite light sources. It's a mercury vapor lamp. This operating principle is the same as the metal halide. The current just passes through the gas in the tube, the argon gas, heats up the mercury until it vaporizes. The mercury vaporizes into the arc stream, and the intensity of the arc increases as the lamp warms up, and the arc produces light by itself. So it doesn't need a phosphor coating to produce usable light. This particular model is a 175 watt clear, and it's made by Philips, but it's the good old Westinghouse Lifeguard lamp, because Philips bought out Westinghouse. So this is a good old Lifeguard, and one of the best mercury lamps ever made in history. These things have been known to last as much as 50 years in service. These lamps are a venerable light source, so these lamps still have viability today, even though they're trying to phase them out. And they are indeed an energy efficient light source. And the lamp produces kind of a pretty color. It's a blue color. It's around 6,800 degree Kelvin color temperature, and it's a pretty blue light. Not very good color rendering. It only has a CRI of about 15. If you put your hand underneath it when it's lit, your hand will look green underneath it, but it's still good enough to see colors under, like a car parked under it or whatever. Another thing about mercury lamps is they take about 5 minutes to warm up when they're started from cold. And once they're at full brightness, if you shut them off even for a second and turn them back on, they'll go out and they will not relight until they cool down for between 5 and 10 minutes. Same thing with metal halide lamps. High pressure sodium lamps have the 5-minute initial warm up, but if you shut them off when they're hot, they'll restrike within a minute after the power comes back on. The clear mercury vapor lamp really shows how the lamp operates, and similar to the metal halide, it's got 2 operating electrodes, which are clearly visible, and a starting electrode, which is much tinier. You can't really see it. There's a tiny little piece of tungsten wire. And the starting electrode is there, by the way, because it reduces the amount of voltage necessary to start the lamp, because it's so close to the other electrode, main electrode, that it sets up a little voltage between it and strikes the gas. Once the gas ionizes, the arc strikes in the lamp and it runs. So it's only there for starting, and once the lamp is running, the arc runs between these 2 electrodes. The arc runs through strictly mercury vapor. There's nothing else. No halide salts, anything like that in the lamp. So it's strictly a mercury discharge at medium-high pressure inside the arc tube at high intensity. This is the GE bonus line. This lamp is known as a C lamp, or color improved lamp, and it's one of the earlier phosphor coated mercury lamps, and this one dates back to 1963. The phosphor coating on the inside of the bulb is similar to the phosphor coatings used on fluorescent lamps, and because the arc tube inside is made of quartz transmits ultraviolet light readily. It doesn't block it. So the arc tube gives off quite a bit of UV radiation when it's in operation. So the UV strikes the phosphor and makes it glow. And in this case, this phosphor glows an orangish color. And add that to the blue glow of the mercury vapor, and you'll get a lamp that's got a beautiful yellowish white color. And it's much better color rendering. Objects lighted by, show their colors better. Puts out a little less light than the clear lamp, but what it loses in light output, it gains in color quality. And then there's a later type, which I have here, in a smaller wattage, and this one has the auxiliary gear to run it as well, the ballast. This one's a 50 watt mercury vapor, which is the smallest size they ever made. It can run on either 40 or 50 watt, depending on the ballast that it runs on. And the phosphor on this lamp, as you can see, is a whiter color. It's because it's a different phosphor. It's an yttrium vanadate phosphor, and it's actually a type of rare earth phosphor. And this phosphor is much more efficient than the old C phosphor, This not only improves the color of the light with the yttrium vanadate, but it increases the light output. This lamp actually puts out about 15% more light than the equivalent clear lamp, while at the same time providing a crisp, cool white color of light, almost like a cool white fluorescent, with pretty good color rendering, so you can even use them indoors. A lot of street light fixtures use these deluxe white lamps up until high pressure sodium came around, and there's still some of them in use, and they're easy to identify. Any street light you see that lights up a crisp, cool white color has this type of mercury lamp in it, with the yttrium vanadate phosphor. Probably in a bigger wattage, 175, 250, 400, maybe 700 or even 1,000 watts, depending on the fixture.